Before we continue, I want to have our spotlight one here to be exactly how I have it in my original scene. To do that, I created a setup, a pose preset that will adjust the light exactly how it was originally. So the light is here, it's pretty close to the original, but let's see how we could perform this operation. So I have the spotlight one selected, and I can go in the File, Merge menu, and I'll go to the Lesson 3 folder where I have all the light presets and other presets stored. The file for this light is the window light pose.dsa. Now, before I click on Open, I have to do something else, because if I do this, what it will happen is that this light will be set up correctly, will be positioned in the right place, but every other light will be removed from the scene. So this is important to remember, because you thought by using File Merge that this operation would kind of merge together all the setups. This is not what happens. Studio will actually remove all the other lights, but there is a workaround. If you press and hold the Command key on Macintosh or the Control key on Windows while clicking on Open, this dialog box will appear, and this is a light preset dialog box that allows you to adjust the behavior. So as you see, the action is defaulting to replace all, and we want to just select replace selected, which means that the selected light, in this case spotlight number 1, will be replaced with the light preset that is in this file, in the file window light pose.dsa. So we want to change this and then click on accept. Now keep an eye on the light, it's right here, and we'll see what happens when I select accept. There you go. So it has moved in this other position here. So now it's pointing perfectly in the same way, and the other two lights, as you can see, are still here. So far, we have taken care of the basic requirements of lighting for this scene, but all our light sources are behind our character. The only thing that reflects some light back to her face or outfit is the floor. So we need to add some more lights to create the mood and produce that sculpted look, that chiaroscuro effect that gives depth to an image. Chiaroscuro is an Italian term used to identify painting that used a high contrast between light areas, chiaro, and dark areas, scuro, of the image. The shading used by chiaroscuro painters provided a sense of depth and 3D shape of the form that would not be perceived when looking at pictures that were painted with a very flat light. If your image is evenly dark or evenly bright, it will likely fail to provide that sense of depth that we find very interesting. In many comic books, the use of very strong shading exalts the heroic proportions of the characters. I find that a good tool for this kind of effect is a nice side light. I want my light to shine from the right side of the frame toward the character and light her side. For this, I will use my softbox with a very long snoot to keep the light from spilling on other parts of the scene. So let's add the softbox and let's move it to the side, pointing to the character. have, of course, the position and rotation of the one that I used in the original image. So let's see. It's 618.87 for the X position, minus 24.38 for the Y position, 146.93 for the Z position, minus 344.97 for X rotation, minus 96.70 for Y rotation, and minus 12.25 for the Z rotation. And let's enable the snoot. The snoot is scaled in the Z-axis at 26.8%. Of course, all these adjustments were done by eye originally. The point of reusing the exact coordinates here is to make it simpler and quicker to get the right setting. You should experiment and change things to reflect your own taste. The snoot is visible in the frame, and so we are going to just resize a second. And this is just a temporary fix, as we will see later. There. Let's do a quick render and see how this works. But before we do that, we better give a name to the light group for the softbox so that we can adjust it in Lux. I'll call this side. Alright, let's hit render and see what happens. The result is definitely there, but the light is just too wide. This is where the softbox shows its strength. Since the light is controlled by the snoot, we can aim it quite accurately, avoiding undesired spills. If you think about it, the shape of the softbox will affect the shape of the light projected. You can make it narrow so that it becomes a very thin ray of light. Remember, the size of a light changes how the light performs. In our case, we are going to scale the light down to 86% and then further down on the x-axis to 26.9%. This will make the light much narrower. And during my early tests, I found that the light was spilling too much on the floor, so I reduced the vertical scale, which in Studio is on the y-axis, to 65.6%. This moves the bottom of the light away from the floor, achieving the result that we want. At this point, I can bring the snoot back to the original size. It was 28.8%. And now we see that because of the scaled softbox, the snoot doesn't show in the frame. It's just outside, which is exactly where I want it, and but it's not showing in the frame, which is marked by this white outline. Let's try a new render and quickly check our result. Excellent. We are getting much closer. I think that I want that side light quite a bit dimmer. Let's try 70%. Let's see, 60%? Better. Okay, let's save that value in reality. And now we can continue with the other lights. The render so far is promising, but I feel that I want some more direct light on the character to bring out the eyes. So I'm going to enhance the reflection that there is from the copper ring with a mesh light just out of frame in front of the character. First, let's add a new mesh light. I'm going to change its name so that I can easily identify it. I'll use Reality Light _ eye light. As usual, to create a mesh light, we name a light with the prefix Reality Light, followed by some identifier of our choice. In this way, Reality automatically converts the object into a light. Alright, now let me show you where I want this light approximately. This will be shining up toward her face and hopefully bring out her eyes. Whenever we see a face, we are drawn to the eyes. If they are in the dark, the effect could be unpleasant. The correct parameters for this light are the following: X position 25.46, Y position 50.18, Z position 233.62, X rotation minus 51.8, Y rotation minus 0.58. I also want to make this light fairly small so that it is more targeted. I'll set the scale at 50% because this is meant to simply create a bit of highlight. I'm going to lower the power of this light to 2 watts. Finally, I'll create a light group named Eye Light for it. Let's try a render at this point and see how it looks. Almost there. There is one more light that I want to add. I want to make this sword blade more prominent, more shiny. Now, shining a light at a very polished piece of metal is not going to work. What creates the visible effect of metal is a large reflection of a light color material, like white, not direct light. Direct light will just cause a very bright spot in the image with no details. If you try this in real life, you will see what I mean. Take a common steel knife, place on the table, and take a picture of it with a camera flash. You will see just a bright light reflected back at you. So, we want to use a simple white plane placed in a strategic point. Now, that is a bit tricky, as you have to judge it by eye. Let's begin. We add a plane primitive and move it into position. It's better to use the Scene tab to select it, given all the objects that are already in the scene. I'm going to rotate it so that it's vertical. And I'll use a simple technique to make it easier to position it in front of the blade. I bring it closer to the sword until it connects to it, so that I can see the alignment. I then move the plane to the right until it's out of frame. In this way, it's very likely that a part of the plane will be reflected in the blade. Also in this case, I have some coordinates to make it match the reference render. X translation is 192.14. Y translation is 83.39. And the Z translation is 127.68. Rotation for X is 14.53. For Y is 6.17, and for Z is 88.84. Lastly, the scale is 121.3%, plus we need some additional adjustment for X at 48.1% and Z at 76%. While this plane is in the right position, it needs a bit of help to be more visible. I use a spot to shine the light to it and make it more bright. I could have turned the plane into a mesh light, but using a spot to reflect light shows another technique that brings a bit more flexibility in this case. The light is bounced off the plane at a certain angle, and the plane is lit in a less even way because the cone angle of the light and the feathered edge. The effect can be preferable in certain situations. You have to experiment and find out what works for you. The parameters for the light are X at 97.13, Y at 30.66, Z at 275.88, X rotation 8.67, Y rotation minus 35.89, Z rotation 12.10. The cone angle or spread angle is 17 degrees. Let's call reality. Assign a light group to this light. Let's call it sword light. And change the gain. I just need a hint of this light, and I know the spots are quite bright. I don't want to flood the scene with light from this spot, so I set the gain at very low 0.02. Let's do a test render. This looks good, but I see that the sword light is actually too dim. Not a problem, we can increase the brightness a bit. Now, by making the light brighter, I get the right effect at about 6 times the gain. But I also get a lot of spill on the back wall. That is something that I don't like. We can simply place another plane there to block the light from escaping. This kind of light control device is called a flag, and it's usually matte black to avoid any light reflection. Okay, let's add another plane. Rename it flag_01 and move it in place. I will type the parameters to go a bit faster. Let's see. X is at 225.67, Y at 77.86, Z at 82.99, X rotation 84.26, Y rotation minus 0.0059, Z rotation minus 1.08, and the Z scale is reduced to 71%. There. Now, just to make it clearly visible as a flag in Studio, I set its material to pure black and glossiness at 0. So Reality will take it directly as having a matte material. Let's call Reality and do a quick test render. Now we see that the flag is blocking the light from spilling on the back wall. This is what I was referring to when I mentioned light control. Start thinking about light as being something that you can direct, shape, and block. Blocking is as important as anything else. And remember that you can use your real lights to experiment and learn and recreate that experience in Studio. All right, it looks like we have all the elements in place. Let's save the scene and take a break. In this lesson, you saw how we need different types of light to paint the image. We saw how to use the softbox to add a side light, and we saw that we can change the shape of that softbox to help us shape the light. We also used the snoot to avoid spilling light onto other parts of the scene. We saw how to block lights and how to bounce them off a plane to create reflections for a shiny surface. We have put together a complex light set in which each light has a reason to be there. This is the foundation of every lighting plan. In the next lesson, we will add the hair and fine-tune the materials. See you there.